The apply function is another loop function that's used to evaluate a function over the margins of an array. Usually the function is going to be an anonymous one like we showed with lapply, or it could be a function that already exists like the mean, for example. It's usually used to apply a function to the rows or columns of a matrix. Of course, matrices, which are two-dimensional arrays, are going to be the most common type of array that we're going to use in R, but you may have three-dimensional arrays and such. But you can use apply on general arrays, such as taking the average of an array of matrices, for example. One thing to note, and you may hear this out in the wild occasionally, that using apply is somehow better than using a for loop, or somehow it's faster than using a for loop, and that's generally speaking not true. It was true a long time ago in older versions of the S language in R, but right now it's not true at all. The main reason you want to use a function like apply is that it involves less typing. And less typing is always better because good programmers are always lazy. So apply is very useful in particular on the command line, because on the command line when we're interacting with data, we're doing exploratory analysis, you want to do as little typing as possible because it just makes our fingers tired. So how does apply work? So the first argument x is an array. So an array is a vector that has dimensions attached to it. So a matrix is a two-dimensional array, for example. A margin, which I'll get to in a second, but this is a vector, an integer vector that indicates which margin should be retained. And the last important argument is the function that you want to apply to each of the margins. So, and then the ... argument are other arguments that you want to pass, include other arguments that you want to pass to the function. So here's a matrix that I'm creating. It has 20 rows and 10 columns. So in the matrix, it's just normal random variables that I've generated. So when I apply, so what I'm going to do is I want to take this matrix and I want to calculate the mean of each column of the matrix. So the way I can do this is I can use the apply function on x. I give it the margin 2, and I'll say what that means in a second, and then I pass the function mean. And so what happens is I get back a vector of length 10 that has the mean of each of the columns of the matrix. And so the idea is that the matrix has 20 rows and 10 columns. And so you can think of the matrix so dimension 1 has 20 rows and dimension 2 has 10 columns. So when you apply the function mean over the matrix, the idea is that you want to keep the second dimension, which is the number of columns, and you want to collapse the first dimension, which is the rows. So the idea is that you're taking the mean across all the rows in each column, and then you're essentially eliminating the rows from the array. So what you get back is actually has one of the dimensions has been eliminated. It's really the first dimension that's been eliminated, and so you get this number, this vector, which has each of the means for each of the columns. Similarly, you can take the means of all the rows of the array, and I can call the apply function on x. I give it the margin 1, which means preserve all the rows but collapse all the columns. And here I'm calculating the sum of each of the rows instead of the mean. So I cast it the 1 because it says because what I mean is I want to preserve the rows and collapse the columns. So here I got a vector of 20 because there's 20 rows, and inside each and for each row I calculate the sum of that row. Now for simple operations like calculating the sum or calculating the mean of a column or of a row, there are special functions that are highly optimized to do this very quickly. So for calculating the row sums and row means, there's the function row sums and row means, and similarly there's call sums and call means, which do the same things for the columns. These are equivalent to using the apply function, but they're very much faster than using apply because they're optimized to specifically do those operations. So if you want to calculate the sum or the mean of a column or row of a matrix, use those functions instead. Now you can use the apply function to apply other types of functions. For example, suppose you have a matrix. Here I've generated, again, a matrix of random normal variables. That's 20 rows by 10 columns. And suppose I want to go through each row of the matrix and calculate the 25th and the 75th percentile of that row. So I can apply on x, and I pass it the margin 1, because it means I want to preserve the rows, and then I'm going to pass it the quantile function. Now the quantile function needs the quantiles that you want to calculate, so there's no default value for that. So I actually have to pass it to the quantile function through the dot 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 argument of apply. So here, the argument for quantile is called probs, and I give it 0.25 and 0.75, meaning I want to calculate the 25th percentile and the 75th percentile. So what this call does is it goes through each row of the matrix, and for each row it calculates the 25th and 75th percentile. So for each row there's going to be two numbers that are returned. And what apply will do is it'll create a matrix that has two rows, and the number of columns is equal to the number of rows in this matrix, which happens to be 20. So here I'm getting a 2 by 20 matrix where in each column of this returned matrix, I've got the 25th and the 75th percentile for the corresponding row. So for example, in the first row, the 25th percentile is minus 0.33, and the 75th percentile is 0.92. And in the 16th row, the 25th percentile is minus 0.95, and the 75th percentile is 0.88. So you see how that works. Now, suppose I had more than just a matrix. Suppose I had an array that I want to do something with. So here I'm creating an array which has normal random variables, and it has two rows and two columns, and it's 10, and the third dimension is 10. I guess I'm not sure what you would call that dimension. But you can imagine this, you can think of this as being, there are a bunch of 2 by 2 matrices that are kind of stacked together. And the idea is, like, you can imagine I have a bunch of 2 by 2 matrices, and I want to take the average of those 2 by 2 matrices. So the average of a bunch of 2 by 2 matrices is going to be another 2 by 2 matrix, which is the mean. And so I can call apply on this array, and I want to keep the first and the second dimension, but I want to collapse the third dimension. So here, when I give the margin, I give it 1 and 2, which I want to preserve, and then 3 is not there, which means I want to collapse the third dimension. So here, and the function I pass it is the mean. So what this will do is it'll take my array, and it'll average over the third dimension and give me the mean matrix. Another way that you can do this is to use the row means function. So even though this isn't a matrix, you can apply row means to an array, and you pass the argument dims equal to 2.